Hello. Functions, ups and downs, evens and odds. Today we want to continue our discussion about the graphs of functions by noting where the function goes up or is increasing, where it goes down or is decreasing, and we also want to discuss what we mean by even functions and odd functions. We've talked about the ins and outs of functions, in other words, the inputs and the outputs, and we've given illustrations of how functions can be used to make predictions in the real world by looking at their inputs and outputs. Now we are going to talk about the ups and downs of functions. A function f is said to be increasing on an open interval of x values if its graph from left to right on that interval is rising or going up. A function f is said to be decreasing on an open interval of x values if its graph from left to right on that interval is falling or going down. Notice that when you are asked where is a function increasing or where is it decreasing, your answer should be in terms of an open interval of the x values, not the y values. A function f is said to be constant on an open interval of x values if all the corresponding values of f of x of the graph on that interval are the same. The function value f of a is a local or relative maximum value of f if f of a is greater than or equal to f of x for all x in some open interval containing a. We say that f has a local or relative maximum of f of a at x equals a. We also say that the point a f of a is a local or relative maximum point. Local minimum is defined similarly. The function value f of a is a local or relative minimum value of f if f of a is less than or equal to f of x for all x in some open interval containing a. We say that f has a local or relative minimum of f of a at x equals a, and we say that the point a f of a is a local or relative minimum point. To understand these concepts better, look at the following example. Sometimes I think you can get lost in mathematical verbiage, but looking at a picture will suddenly make it very clear and easy to understand. In this graph, we have a function f, which is this blue curve, and we might ask ourselves, where is this function increasing? The function is increasing or going up from left to right as x coordinates go from minus infinity to minus 3. The function is also increasing or going up from left to right as the x coordinates go from minus 1 to 2. And finally, the function f is increasing or going up from left to right as the x coordinates go from 4 to infinity. So the function is increasing on the open intervals minus infinity to minus 3 and minus 1 to 2 and 4 to infinity. Where is the function decreasing? The function is decreasing or going down from left to right as the x coordinates go from minus 3 to minus 1. It's also decreasing or going down as the x coordinates go from 2 to 4. So the function is decreasing on the open intervals minus 3 to minus 1 and 2 to 4. You notice that we gave our answer in terms of x coordinates, not the y coordinates. Now, where does this function have relative maxima? If you look at this point, the y coordinate of 2 is the relative maximum value of the function in an open interval around this point. So we say that 2 is a relative maximum of the function that occurs at x equals minus 3. Notice that 2 is not the absolute maximum of the function. Over here on the extreme right, the function is going up toward infinity, but 2 is the maximum value of the function in an open interval around this point. We also say that the ordered pair minus 3, 2 is a relative maximum point of the function. There's another relative maximum point of the function here at the point 2, 1. 1 is the relative maximum value of this function that occurs at x equals 2. If you think about an open interval around this point, you'll see that 1 is the largest y value of any of the points in the neighborhood of this point, or an open interval around this point. What about local minimums? If we look at this point, we can see that the local minimum value of the function f is negative 3, and it occurs at x equals minus 1. And over here, there's another local minimum value of minus 1 that occurs at x equals 4. Here, you can again tell that negative 3 is not the absolute minimum value of this function, because over here on the extreme left, the function goes down toward minus infinity, but negative 3 is the smallest y-coordinate of any point in an open interval around this relative minimum point. Informally, you can think of a relative maximum point as the peak of a hill, and a relative minimum point is the bottom of a valley. Notice that the function changes from increasing to decreasing on either side of this relative maximum point. The function changes from decreasing to increasing on either side of this relative minimum point as we go from left to right. Another concept related to the graphs of functions concerns whether the function is even, odd, or neither. A function is even if for every x in its domain, f of minus x equals f of x. Another way to say this is that a function is even if for every xy on its graph, the point minus xy is also on the graph. This will make the graph symmetric with respect to the y-axis. A function is odd if for every x in its domain, f of minus x equals minus f of x. Another way to say this is that a function is odd if for every xy on its graph, the point minus x minus y is also on the graph. This will make the graph symmetric with respect to the origin. Let's look at some examples to help you understand this better. Suppose f of x equaled x to the fourth minus 3x squared plus 5. Then f of minus x would be minus x in parentheses raised to the fourth power, subtract 3 times minus x in parentheses squared plus 5. Well, a negative sign raised to an even power is positive. So this simplifies to just x to the fourth minus 3 times x squared plus 5, which is f of x. So in this particular case, f of minus x equals f of x. That means this function is even, and its graph would be symmetric with respect to the y-axis. Here is the graph of this particular function. I think you could see that if this were a piece of paper and you folded it along the y-axis, the two halves of the graph would exactly overlap. So that's what we mean informally by saying that it's symmetric with respect to the y-axis. Here's another example. Suppose f of x equaled x over x squared plus 1. Then f of minus x would be minus x over minus x in parentheses squared plus 1. That would be minus x over x squared plus 1, because this minus sign, when it's squared, becomes positive. The minus sign in the numerator here can be moved in front of the fraction, so this would be minus x over x squared plus 1, and that's simply minus f of x. Since f of minus x equals minus f of x, this function would be an odd function, and its graph would be symmetric with respect to the origin. Here's a picture of the graph. Notice these 2 points, 1 and 0.5, and -1, -0.5. This graph is symmetric with respect to the origin. It's an odd function. Here's a final example. Suppose f of x equaled x to the fourth plus x cubed. Then f of minus x would be minus x in parentheses to the fourth power plus minus x in parentheses cubed. The minus sign raised to an even power is positive, but the minus sign raised to an odd power is negative. So we end up with x to the fourth minus x cubed. F of minus x then does not equal f of x. X to the fourth minus x cubed does not equal x to the fourth plus x cubed. But f to the minus x does not equal minus f of x either, because minus f of x would be minus x to the fourth minus x cubed. Since neither one of these is true, this function is neither even nor odd. Hopefully, looking at these other aspects of the graph of a function, determining where the function is rising or increasing, where it's going down or decreasing, where it has relative maximum points or relative minimum points, and whether the function is even or odd, what kind of symmetry the graph has, will help you notice these features and appreciate them more, be able to understand the graphs of functions a little bit better. If you go ahead to take calculus someday, you will learn how to calculate the places where a function is increasing or decreasing and where it has relative maximum or minimum points without looking at the graph itself, but just from the equation of the function. That will have tremendous applications in a wide variety of areas. So I hope you will consider furthering your math education even after you complete college algebra. There are a lot of more exciting things ahead as you continue to study mathematics.